Hello and welcome everybody. Today we're going to be talking about chemical reactions. Okay, so chemical reactions. So there are many of them. Okay, that's just a key thing you just gotta know. Alright, but we're only going to focus on 5 of them. Alright, so and then basically those 5 we have are this is called synthesis, decomposition, we have single replacement, you have double replacement, combustion. So, and combustion. So, and let's just, these are our 5 main ones right here. And, alright, so these are pretty much the 5. And oh, it does change. Anyways, just know that these are the ones that should be highlighted red in your notes and mainly focused on. And of course, we gotta know the topic, chemical reactions. So here's how it works. Synthesis is basically in the chemical format, you do A plus B equals AB. And so I just love to think about this as a couple called Ted and Sue. I'm making this up, so if your name is Ted and Sue, do not freak out. And you know, it'll be Ted Sue. The couple becomes Ted Sue. So, and you can also think about it in chemistry type ways, because you can have H2, and the software doesn't have a subscript type thing, but basically it's H2, and you can have H2 plus O2, which will give you H2O, or in other words, what we all live by and what we all need, water. Alright, so, and then synthesis. So, that's just what it is, synthesis. That's pretty easy to be told. Yeah. Alright, so these are just some examples out there I'm throwing out, but synthesis, the key thing about it is, key statement, synthesis actually has one product. Alright, it's just one product, or a thing that is on the right hand side of the arrow. Now, I notice you're going to be like, well, I didn't use arrows, I used equals. That's my mistake, actually, guys. And actually, because I'm looking at the keyboard, and I should be looking at the whiteboard tools as well. So I'm sorry, I want to fix that up. Like, right now, like, legit. Okay, and I want to, you know. But, yeah. But the A plus B is fine. So this is how it looks like. So what the statement means like this. Okay, and then you can do it also like this, right here. Bingo. Right? So that's how it is right here. Now let's move on to the next thing, which is called a decomposition reaction. So the decomposition reaction is, or basically, this is how it's done by. And let's change the color. I just love changing color. It just helps me learn. I'm just going to use bright red. Okay, yeah, alright. So decomposition reaction. Here you have example. Here you have A and B, or equals A plus B. I didn't press my shift key. There we go. Alright, so basically this refers back to Ted and Sue. So you know, think about like Ted and Sue having a fight every 5 days. So here you have Ted and Sue. So today, let's say today is the 5th day in their relationship, and then they're sort of all alone because this is what happened. So now it's Ted plus Sue, but not together. They are separate. The trick to this is, or the key statement slash idea slash trick is that, well, I'm going to space this down here. Space all this down. Alright, so as you can see here, that this right here is Ted and Sue, and this is just Ted and Sue being separated, and I'm going to use a different color arrow. So we're just going to use that, and then you know what, just so that they're together, you know, we'll use that. So basically the key trick is that here that you have a reactant breaking up. Sorry. The key idea is that you have a reactant that breaks up. So here's a reactant breaking up. Alright? And now, things you should know about this is that, well, the chemical example I didn't give you guys. So basically a chemical example would be like this. H2O, and now it's just separated to H2 plus O. Now you're gonna be like, well, how come oxygen, you know, doesn't? Sorry. Yeah, 2HO2. So you're gonna notice that, like, well, how come hydrogen has a 2 to the left, and then this 2 that should be a sub 2. Well, hydrogen only has 1 charge, and oxygen, on the other hand, has according to the periodic table of elements, yeah, oxygen has a negative 2 charge. So alright. So you're gonna wonder, well, how did this come about? Well, oxygen has a negative 2 charge. So and the only reason why it's O2 is because oxygen is one of the elements that on the periodic table from there. So it's negative 2 and times 2, which is, you know, negative 4. But on the same hand, hydrogen has 1, and so that's why it has to make out to, but it has, you know, you see that it's gonna form, I think it's called hydroxide, I'm not sure, but you see that it has H2, and so the charge over here, and I'm gonna make this, you know, yeah, this is negative 4. And so we need to have exactly amount of 4 over here. So here, oops, there I go. All the way down here, I'm going to say 4. Because it has, so negative 1 times, or sorry, it has 2 already, and then basically if you multiply those two out, you get 4. So this totally satisfies the equation. But on H2O, you have it like this, because presumably you're saying that this, if you right. So yeah. Alright. So now let's move on to a new page, and let's get the single replacement. Now here in single replacement zone, I'm not calling it zone. Now we're talking about single replacement. So let me see if the color's right. Right. So in single replacement, what we have is your format is A, B plus C. And I just want to go back for a minute, see if I gave you. Oh, yeah, I did give you that format for a chemical equation or chemical reaction. No, ignore that anyways. Okay. A plus B plus C. Alright, so, and then in the result, it yields you out with an equal to AC plus B. And this is basically going back to this perfect example of Ted and Sue back again. So you can have Ted, Sue, and then let's just say somebody named Bill comes in. And so if Bill comes in, so now, let's just say they've had another fight, or Ted and, let's say Ted and Sue have had another fight, and so now Bill comes in. Alright, so Bill takes out with Sue, and Ted is left alone. So it's Sue, Bill, and Ted. Or, you can have Bill, Sue, or Ted. Depending on how you wish to have it, but alright, so anyways, in single replacement, you gotta know that anions replace anions, and cations replace cations. Okay, so an example in chemistry could be like this: Na. So this is sodium chlorine. So this would be sodium chlorine plus iron 2. And notice that, yes, the 2 has to be a subscript. And if you guys, actually, I didn't realize this, but okay. Let's just have it like this: Na, not a good writer though, Cl plus F over 2, like that. That's how I'm gonna modify it towards. So now, but here's what happens. Na joins with F2, or F simply. It's like, oh my gosh, I like you. And then, alright, and then poor chlorine is left alone with a 2. And then, of course, alright, a little mistake here. I was too eager to get to the chlorine's side. So, this is how it would look like. These two bond, and then, yeah. Okay, so basically, you're gonna notice that there's a key statement to this, or an idea. Slash statement. Alright, so that is basically a compound plus an element is equal to a compound plus an element. we can see that being proven because we can prove this because a compound, NaCl, is a compound, and an element is iron. But now, when we had these, when we did the single replacement of these, we have another compound now with an element left alone. And if you refer to your periodic table, you will notice that the sodium is basically has a charge of 1, right? And you're going to notice that, well, iron is also, it's a transition metal. And so you're going to notice that, hey, these are like non-metals, basically. And chlorine, on the other hand, is a metal. So you basically just have modeled an anion replacing an anion. Alright? So the last two I have to teach about are basically double replacement. So let's get on with it. And I'm going to use different color. Alright, I'm just going to stick back with blue or black. Black is fine. Double replacement. So in double replacement, you're gonna have we're gonna go back to the story of Ted and Sue and Bill. So what happens is Ted and Sue, broke up, and this is a recap basically. Oh no, actually forget the recap. Okay. So Bill finds another person called Jill. Bill and Sue. So after Bill and Sue get together, so Ted finds Jill somewhere. So Ted and Jill come in, and then you have Ted and Jill. So we call them Ted Jill plus Bill and Sue. So Bill Sue. Alright. So now here's the thing with double replacement in the story. So when they met up at the dance, these couples switched off each other. So yeah, it's a real weird example I'm giving, but this is the best way. Like, this is how I remember all of this. And of course it comes from a story in chemistry. So here's Ted goes off back with Sue because he's like, oh my gosh, she is so pretty. And Bill is like, well, I'm alone, now I'm gonna go get Sue. Oh, sorry, Jill. So now you have Bill and Jill. So that's their story. And and so what happened? So what else is going on is that we could use a chemical example for this. So I'm gonna write this out because I don't know if my teacher were to see this, she would be really happy at what she saw if she knew that I was, didn't have my subscript there. But we have Al, or aluminum, bromine through sub 3 plus plus is not right, plus potassium sub 2 and sulfate, so SO. And if you don't know your polyatomic ions, please, you're already in enough trouble, just learn them. 5 a night, 6 a night, it's not that hard to memorize them. Plus, so I got really big, so I'm going to move over here down to the next line. yeah, AL squared SO3 SO4, and then you're gonna write 3 to the sub 3 here, plus you're gonna write 6 Br, or 6 potassium bromine. So what happened here is we're going to notice something, and I'm going to get to that. Notice the trick and everything, but what happens here is that in bromine 3, right? Well, bromine 3 is basically a compound. So you're going to notice that hey, this is a compound. This right here is a compound. You're going to notice that this right here is a compound, and on top of that, you know, the last one is also in this equation a compound. And so there's a trick to this. Now the trick is basically in this example right here we have, the trick is that you have compounds, oops, in the end of the product is what I'm going to call it. And yeah, I know you guys can't see it. I'm gonna make a change. I'm gonna make it red. So there you go. There you go. That's what it is. That's what your key idea / trick to this is. You have compounds in the end of the product. Now, combustion is really interesting. There are 2 types of combustion, and I want to get to that. So combustion here is basically when you have 2 types. You have it written out like this. And I'm going to use my pen. I'm going to use blue. I'll use maybe a maroon color. So basically you have 2 types. So the first one I'm going to label is incomplete. So C, you'd have a subscript down here, you'd have H, and then you'd have a subscript down here, you have plus O2, right here. So and then right here, this right here, once again, is incomplete. Alright, and let's get to a complete example. So a complete one would be CO2 plus CO plus H2O. Now, so here's the thing. Here's how you can tell if it's combustion. Complete formula. It has everything just filled in. It's super, easy. It's just, you're like, oh yeah. This is. You can just tell it's combustion because of how it's written and all of that. You see all this, all of this, and you're like, this is interesting. And on the other hand, you can tell that combustion reactions are incomplete. You can tell if it's not complete is because if you go back, you get to see all of these, charges, and you're going to see plus O2. But another difference is that Well, in one, water is written out, which is combustion. So what I mean by that is water itself is very complete. That's combustion right there. That's complete combustion. That's a great way to like sort of tell the difference. And you're gonna notice that here, let me just get a box and let me show you. Here, that in incomplete combustion, you have this. So yeah. But other than that, guys, that's pretty much it. Thank you.